5.1, we're going to be going back to those identities that we started with in the previous chapter. So this first page is all about reviewing those identities, knowing them. Again, if it's a cofunction, cofunction means sine and cosine go together and that their angles are complementary. They add up to 90 degrees. So here, these are cofunctions. If I do sine of 23, that's going to equal the same value as cosine 67. Those have the exact same values. If you're unsure, go ahead and punch it in your calculator. As long as you're in the degree mode, sine of 23 and cosine of 67 have the exact same value because they add up to 90 degrees. And the same thing happens when we're in radians, except for they don't add up to 90 degrees, they add up to pi over 2, the radian equivalent. And also going back and reviewing these sine and cosecant and tangent and cotangent, these are odd functions because they reflect over the origin, whereas secant and cosine are even, and they're going to reflect over the y-axis. So that's just kind of review of things that we've talked about already in the previous chapter. We're going to be using a lot of these identities to be able to solve and simplify and evaluate. So let's start looking at some examples, and that's pretty much all these notes are, is there's just tons of examples on how to use this stuff. So here we have secant of u is -3/2, and the tangent of u is 0. So secant is related to cosine. Cosine negative is quadrant 2 or quadrant 3. Tangent u is greater than 0, means positive, tangent's positive, and if tangent's positive, it's quadrant 1 or quadrant 3. So quadrant 3 is where this problem is existing. I'm going to draw a picture in quadrant 3 where I know cosine is, the secant is the reciprocal of cosine. So this is my hypotenuse and this is my adjacent. So -2, 3. Oops, I'm sorry. 3 is over here. And then we can use the missing side Pythagorean theorem to find the square root of 5. So if I want to find all 6 trig functions, I can now do sine. I know cosine's the reciprocal, tangent, and then go through all 6 of those, and you should be able to fill those in. When we're simplifying here, we need to use our identity properties. Anytime we have a square, that's going to definitely use one of our Pythagorean identities. So in this case, cosine squared is 1 minus sine squared. Go back to those identities or flip the page to the page 1, because we want to make this as small as possible. Now I can distribute, so I get sine minus sine cubed. And sine minus sine is just negative sine 3. Sine cubed there. Whenever we have fractions, we do want to look to have common denominators. So I'm going to multiply the first one by sine and the second one by 1 plus cosine. So that I'm going to get sine squared plus cosine squared all over 1 plus cosine times sine. Well, from my identities, I know sine squared and cosine squared is 1. Now I have 1 plus cosine on top and 1 plus cosine on the bottom, so that'll go away, leaving me 1 over sine, which is cosecant. It's just a matter of practicing and knowing your properties. So until you know them, have that piece of paper out. Alright, sine t plus cotangent t times cosine of t. The best bet is to get everything in sines and cosines. So in this case, I have sine plus cotangent is cosine over sine. So that means sine plus cosine over sine. Again, if I have fractions, I want to get common denominators, so I'm going to multiply this one by sine. So I get sine squared. Oops. When I multiply this, sorry, I get cosine squared there. I'm going to get sine squared plus cosine squared all over sine. I know what sine squared plus cosine squared, it's one of my identities, so 1 over sine gives me cosecant. Alright, we want to rewrite that so it's not in fraction form. In order to get rid of a plus or minus, it's much like our imaginaries and our radicals. We use the conjugate. So be able to use that in this case is 1 minus sine. So I get 1 minus sine on top. I get 1, and then the whole purpose is that my inners and outers go away there. And now I have minus sine squared. This is one of my identities. 1 minus sine is cosine squared. Because it's one denominator, I can separate to 1 over cosine squared minus sine over cosine. And I'm going to rewrite cosine squared as cosine cosine. 1 over cosine squared is secant squared. Again, because this is multiply, I can separate this to sine cosine and 1 over cosine. So that's secant squared tangent and 1 over cosine is secant. And I can leave it just like that. Secant squared minus tangent secant. Okay, so we're going to try that again down here. We're going to do the conjugate of tangent minus secant, which is going to give me tangent minus secant on top. On the bottom, I'm going to get tangent squared. Inners and outers are going to go away, so minus secant squared. So I get tangent minus secant, and this is negative 1, according to my identity properties. So therefore, reduce that, I get negative tangent plus secant, because it's going to switch the signs. Factor, this is a difference of two perfect squares. So secant minus 1, secant plus 1. It's the same as difference of two squares. This is the same as any kind of quadratic. Think of it as like 4x squared plus x minus 3. You can factor this, you can factor with tangents. It's just instead of an x, it's a tangent. We can do this with bottoms up, or we can do our trial and error. You should be able to do trial and error on this to get 4 tangent minus 3 tangent plus 1. 4 tangent is 4 tangent squared, minus 3 and 1 is the negative 3, so we do have to check our inners and our outers. That's 4 minus 3 for 1. Alright, on this next one, notice cosecant and cotangent are different. You must make them the same. Alright, so cosecant squared is the one we want to change because a square is actual one of our Pythagorean identities. So if you look back, cosecant squared is 1 plus cotangent squared. So now I have cotangent squared minus cotangent minus 2 because the 1 and the negative 3. Now this is very much just like a normal trinomial. of x squared minus x minus 2. You're just using the word cotangent instead. So you're factoring it cotangent, cotangent, multiplies by 2, subtracts to be 1, minus 2, plus 1. So it factors the same way, but you got to make sure they're the same. If they're the same, you just factor them as any other trinomial. Alright, so this last page, factoring, this first one, it's just written backwards, so we want to put it in the right form. So cosine 4, 2 cosine 2 plus 1. And with the higher degree, it just means we're splitting it to a square and a square. So we're going to start cosine squared. And multiplies by 1, adds by negative 2. So it's the same thing here. Cosine squared minus 1, cosine squared minus 1. Now this is still a difference of two squares. So they're both going to factor to minus 1 and plus 1. And if they are the same, we want to write them as quantity squared. This next one has 4 pieces. Anytime we have 4 pieces, we're looking at grouping. So I'm going to put the first 2 together and take out a secant squared. So that's going to leave a secant minus 1. Now I want to have the exact same thing here, secant minus 1, so that means I'm taking out a minus 1. GCF secant minus 1. Leftover secant squared minus 1. And you're good. The secant squared minus 1 is a difference of two squares. And combine them. So if it helps you, replace the word with y or x or something, and just factor it as any other factoring, and then go back and put back in the word secant, cosecant, whatever the case may be. Again, we have 4 terms. I'm going to group the first 2 together, so I'm going to take a cosine squared out. So I get cosine squared minus 2. And that's pretty much what I have there. But in order to get the minus, I have to take the negative 1 out. So cosine squared minus 2 is my GCF. Cosine squared minus 1 is my leftover. Difference of two squares. This is not a difference of two squares, so it stays. And this one keeps going. So it's all of the exact same kind of factoring that we've been doing. The only difference is you really have to know your identities. You have to know which ones go together.